Yeah, no.
Which statement about progressive waves is correct?
Yeah, so read the MCQs and tell me the answer. What do you think? So progressive waves are the waves which transfer energy, because I told you there are two types of waves, progressive and stationary wave. So in a stationary wave, the waves are standing, so they does not transfer energy. But in the progressive waves, the difference is that they transfer the energy. So that's why the answer would be D. Okay. The part A means they are always transverse wave. So progressive waves are transverse as well and longitudinal as well. So they both are progressive waves. That's why it's not wrong. They can exist in solid but not liquids. It's also wrong. The decrease in frequency, it is also wrong because velocity is equal to frequency into lambda. So if velocity increases, frequency also increases, right?
Yeah.
Okay, now read MCQ 2.
A cathode ray oscilloscope is used to determine the frequency of a sound wave. The diagram shows the waveform on the screen. The time-base setting is 5.0 meters millisecond division -1. What is the best estimate of the frequency of sound wave?
Okay, so you have to find the frequency, that a time-based setting is 5 millisecond per division. So how many divisions are there for one complete wave? One, two, three, almost three, right?
Yeah. So 3.5.
We cannot say 3.5. It would be something. Wait, just one, two. It's almost, you can say, three, but a more one, two. No, it's 2 point something, right? Why is three? It is ending before three, yes or no?
So 2.9,
Yes, two. Yes, 2 point
2.8.
something. Yeah, you can take 2.9 as well, 2.8 as well. So let's take 2.8 and solve the question for that. So we know 1 over 2.8. Since it is in milliseconds, so multiply by exponent minus 3. Now tell me the answer. What is it coming? Put different calculator and tell me the answer.
357.1.
No, that would be so much. Okay, so sorry. See, 2.8 is just one box. We need it for 2.8 is for three boxes, right? Or you can say
Yes.
we have to multiply it by 5 because it is saying the 5 millisecond per division. So if there's 2.8 for three boxes, so we have to multiply it by 5. Okay?
Okay.
Not I can you can say the value of one division is 5. So that's why we have to multiply it by 2.8.
71.
71. So yeah, B is our answer. Is it clear?
Yes. So that means because the value of one division is 5, and then you must times by the 2.8.
Yes. Okay, try one more thing. Do it by 1 into 3 into exponent minus 3 multiply by 5. Try solving it by this.
66.7.
Yeah, so it could be around 51, 71 years old. Right? Okay, now read this MCQ.
So which question is that? Question number 5, right?
Yes.
Okay. In a progressive water wave, the particles P and Q on the surface of the water are a fixed horizontal distance apart. P and Q oscillate vertically. At time t equals to 0, the wave is as shown. Which graph best represents the variation with time t or the phase difference between the oscillation of the water particle P and the oscillation of the water particle Q?
Yeah, so they are asking us the phase difference between the at point P and at point Q. You know that at point P, it is at amplitude, right?
Yeah.
And at point Q, is it at no, it is at the between of the amplitude. So you can say something. Oh wait. Yeah, so at point P, we can say that it is an amplitude. So where would the particle oscillate, downward or upwards?
Down.
Yeah, you can say downwards because it is now at after this point it will come downwards, right? And at point Q, would it be downwards or upwards? At point Q, it is going at amplitude. It hasn't reached amplitude, it is going at amplitude. So it would be
So that means what?
upwards. So that's why you can say the best part you can say for this part you can say is downwards and for it is for upwards. So B would be your answer. So
And
clear?
so Q is what's because it hasn't reached the amplitude.
Yeah, sorry.
So that means Q is going upwards because it hasn't reached the amplitude.
Yes, yes. It is hasn't reached. It will be reaching. So that's why it has to be upwards.
Okay.
Hmm. Actually, I have opened a wrong one file. So give me a minute. Let me open a right file. Just a minute.
Okay.
Yeah, now.
So give me 1 minute. I just scroll down to the question. The graph shows the variation of displacement y with distance x along a progressive wave at one instant in time. What is the phase difference between points P and Q on the wave?
Yeah, so you know at point P it is an amplitude, so this to this it become one complete wave, then this to half, so it become half wave. So it would be 360 plus 180, which is 5.
540.
Yeah, so that would be your answer. Is it clear?
Okay.
Okay, now read the next MCQ.
Wave power generators take advantage of the energy that is transferred by the motion of waves across the surface of the ocean. The energy of a wave depends on its amplitude. What is the correct definition of amplitude?
Okay, so let's read the MCQ one by one. Part A is saying the average amount of energy possessed by a wave. Amount of energy is not of amplitude. The difference in displacement between a peak and a trough. Is it right or not?
No.
No, because we have to divide by 2 as well. So that's why it's wrong. Now read part C.
The maximum displacement of a point on the wave from equilibrium.
So yeah, this is the right point because amplitude is the maximum displacement per point from the equilibrium. You know, if it is your equilibrium, it is your amplitude. So the maximum displacement would be till amplitude, right?
Yeah.
So C is your answer. No. Okay, now read this question.
So, vibrating.
It's MCQ 50.
The diagram illustrates the position of particles in a progressive sound wave at one instant in time. The speed of the wave is v. P and Q are 2 points in the wave, a distance L apart. What is the expression for the frequency of the wave?
So first tell me that are sound waves transverse or longitudinal?
Longitudinal.
Longitudinal. So in longitudinal, you know we have rarefaction and compression. So it is given you a example of rarefaction and compression, not crust or trough, rarefaction and compression. So you know in transverse we used to say from trough to trough or crest to crest we have one complete wave. So in sound wave we would be saying from rarefaction to rarefaction or compression to compression there will be one complete wave. So at point P you can see that it there's a compression, right? And another compression happen at the end. Yes or no?
Yeah.
So that would be a one complete wave. Now, since we have to calculate the frequency, we know the formula is velocity equals to frequency into lambda. Frequency equals to velocity upon lambda. Uh, Now we have to substitute lambda by length. So tell me, isn't L is equal to half of wave?
Yeah. because
Yes?
it's expression to a rarefaction only.
Yeah, it's compression to rarefaction, right? Exactly. So it would be velocity over pi over 2, so it would be 2v over lambda. So it would be your answer would be C. Not instead of lambda, I would be writing L. Wait a minute. So I have to substitute it by lambda. Sorry. So lambda would be equals to 2L, right? So it would be V over 2L. A would be your answer. Is it clear?
Yes.
Just substitute lambda by ln, so it would be lambda equals to 2L. Now you can substitute it. Okay. Now read this question.
A wave moves along the surface of water. The diagram shows the variation of displacement as with distance along the wave at time t equals to 0. Which graph best shows the variation with time t of the displacement as of the point P on the wave?
So, wave. So the water. So at this point, you can say the direction would be upwards. Yes or no? At point P, direction of the particle would be displacement. You can say would be upwards. So we can say that because it direction displacement, right? Since in the this is a positive direction, you can say the direction at point P would be upwards. So if you make the graph of it, you know after this point the graph should go upwards. Yes or no? Yep. So if we see graph A, you can clearly see it is going downward. It is not possible. If we see part B, it is also going upward, so we can think about it. Okay. In part C, it is going downward, so it is not possible. In part D as well, it is going upwards at that point, so we can also think about it. First, tell me, are these 2 points clear?
So that means at point when you go at point P, that means you will go upwards.
At point P, yeah, there would be up direction of the displacement would be upwards. So that's why I said it will go upwards, not downwards. So that's why the answer would be B or D. Is it clear till here?
Yeah.
Now tell me, what do you think would be the answer, B or D, and why? See, I'm telling you one technique of solving this to make it more clear. The thing is that if you ever have to find what is the direction of displacement of any point on the wave, just do one thing, just draw a wave like this on the initial wave, right? Just draw it. Now again draw a wave a bit further away. You can say a bit further away, so it would be something, right?
Mm.
Just draw a
Yes, sir.
second wave a bit farther away like this. You can say a bit further due to phase difference. So now tell me after P, the next point would be go upwards or downwards? What is
Downwards.
ha- what is happening in the second wave? No, see, after P it is going upwards, not downwards. After P it is going upwards, not downwards. You can see if this wave is coming downwards, then you would be saying downwards. If this wave is coming upwards, you would be saying upwards. So that's why you can would be saying upwards. First, make this thing clear. For finding the direction of the displacement at any point, first draw the wave initial, then draw the second wave a bit further away. You can say a bit further due to phase difference, and then see that at that point is the is that wave above. If the second wave is above, so you will be saying it will move upwards. Okay.
Okay.
If I say at this point, so you can say at this point the second wave is downwards, it will be moving downwards. Is it clear?
So could you repeat one more time?
So I was saying, first you have to draw the wave on the same wave, and then draw the next wave a bit further away with a phase difference. So after drawing it, you have to see that at any point on the wave, is the second wave coming upward or downwards? So you know at point P, the second wave is above, right?
Yeah.
So if it is above, you will be saying that that point will
Upwards.
move upwards. Now if I take one more point, it would be at here. So you know that the second wave is downwards. So you will be saying it will move downwards. So you just have to make an arrow towards the second wave. Is it clear?
Okay.
So you can say the wave you can expect at point P from point P to be something like this. It will go upwards. You can say upwards. So now compare in the options. In part D, you can say it is the most accurate one. In part B, the problem is at point P, is the displacement zero? Yes or no? Is
Yeah.
zero or not? At point P, is the displacement zero or not?
Mm. No.
No, because it is not on the initial, it is not on the starting point, it is in the middle point, right? So how can be displacement would be zero? It is not zero. So that's why part B is not correct. Same for part C. It won't be zero. Why? Because
Because of the displacement.
because point P is not at the start, it is at the middle of the wave. So obviously it has covered some displacement. So that's why D would be your answer. It is going upward as well, and there is some displacement as well. So that's why part D is your answer. Is it clear now?
Okay.
The question was which graph best shows the variation with time t displacement of the point P on the wave. So you know at point P is it here. So it is at the middle. So graph would not start from zero. It should not start from zero because it has covered some displacement. Is it clear now?
Yes, sir.
Okay. Okay, now read the MCQ 54.
A cathode ray oscilloscope is used to display the trace from a sound wave. The time base is set at 5 microsecond millimeter negative 1. What is the frequency of the sound wave?
What is the frequency of the sound waves? So again, you would do the same thing which you did previously. First, tell me how many boxes are there for one complete wave. Quickly tell me how many boxes are there for one complete wave.
About 3.
You can say almost three plus one, two, and it's something 2.8 again, right?
Yeah.
So you multiply it by 5 because one small box is equals to 5 into exponent minus 6 and would divide it by 1, right? Calculate the answer and tell
Yeah.
me the answer.
So it's better to draw a line in the middle, right?
Yeah, it's
When
better to
you
draw a
want to
line.
decide.
Yeah. You can also take it as 3 as well because it is all, if we take from this point, it is coming 3. See, 1, 2, then this point and this point is always coming the one complete box. So you can say 3 here, right? It is almost covering half.
Sorry, sir?
I was saying we can take
So
3 here
no.
because I was saying that we can also take 3 here because if we see from colors, this is almost 0.75 of the box covering. This is one complete box, and this is 0.25. So this one is becoming, these two are becoming one complete box. So you can take 3 as well. So the most closest answer we will be taking. So now tell me what is the value coming?
66.7 times 10 power 3.
67, 66.7.
Yeah. So 67 kilohertz.
Okay, so one more thing. One box is equal to millimeter or not? Did you get this thing? Now one box they are saying is equals to 5 US, but in 5 microsecond into millimeter. So you have also convert this millimeter to centimeter due to it is given as in centimeter. Yes or no?
So that means we don't have to convert it to the SI unit. Just use the centimeter that they give.
Yeah. So instead of 3, we have chosen 3 millimeter box now. So 3 millimeter to centimeter. It would be 3 multiplied by 10. So it would be 30. Yes or no?
Yeah.
So instead of 3 from 30. So you have to see the time based setting. we know that one small box is equals to 5 microsecond, but 5 millimeters. So we have to convert into centimeter. That's why it would be we have to convert it. So we would multiply it by 10. So that's why I wrote 30. Now try solving it.
6.7 kilohertz.
So answer would be C. Is it clear now? Let me explain it from start.
So,
Yeah. Let me explain from start. See, we know that this is three boxes, right? But three boxes mean 3 centimeter, right?
yeah.
But the question is that we want in millimeter. Yes or no?
Mm,
Because the setting is given to us is in millimeter, right?
okay.
So if we convert 3 centimeter to millimeter, what would be the answer?
Three divided by
No, centimeter is bigger unit. Millimeter is smaller. So we will multiply by, if we go from bigger to shorter unit, we always multiply, right? Do you get this thing? If we are going from centimeter to millimeter, we will multiply.
yes, sir.
Okay, so three boxes means 3 centimeter according to the graph, but the reading is given to us millimeter, so we have to convert into millimeter. So we'll multiply, and the answer would be 30 millimeter, right?
Yeah.
So now you can say that these three boxes is equal to 30 millimeter. Now we will multiply it by 5 to calculate the time. To calculate the time into exponent minus 6 because of micro. So it would be 5 1 over 30 into 5 into exponent minus 6. Is it clear now?
Understand.
So this is how you will solve this. You have to take care of the units all the time. Next question. Mm, Okay, now read M347.
The graph shows the variation of the displacement of particles in distance along a transverse wave at an instant in time. The wave is moving to the right, which position along the wave corresponds to a point where particles in the wave are traveling the fastest upwards.
Yeah, so again, they are asking for displacement, right? Because upwards mean direction, right? Right? Answer me.
Yeah,
So how did we solve previously for this type of question? I told you we will first make a wave on this
and then
initial era.
another.
Okay, now and just make a second wave a bit further away, like the phase difference, something
Yeah.
like that. Is it clear in here?
Yes, sir.
Now you have to make points. At point A it is upwards, at point D it is downwards, at point C it is
Mm.
First, tell me at point D, is it upward or is it downward?